This is Zach, the PCB designer. Now that the board has been fully routed and tuned by Wilfred and myself, I can begin checking the defined constraints versus the routing actuals. We zoom in here and take a look at our DDR4 interface. We're going to verify the constraints versus the actual routed values for a few of these byte lanes routed on layer 2. So the constraint manager is a powerful tool that allows the actual routed values on the board to be updated and displayed in the constraint tables. I can now compare these actual values with the constraints that were previously defined by the hardware engineer Kyle. Opening the constraint manager here, I will now update the actuals from the design using the update actuals command. So if we navigate to our net and constraint classes here, we're going to be looking at the DDR4 HPS constraint class, and underneath that the DQ data constraint class. And we'll take a look at byte lane 0 and byte lane 1. So if we open up byte lane 0, and we can use the update actuals command, data update actuals, we now see that the actual values have been filled out in the table with the actual length, the Manhattan length, our delta, and range columns. With the actuals updated, I can now verify that there are no violations between the constraints and the actual values. So I'll verify this for byte lane 0 and byte lane 1. The constraint for the DDR4 byte lanes was defined using this tolerance column parameter. The value was defined according to the specification as 19.685 thousandths. So meaning each net in this byte lane must be within the tolerance value from our target net. In this case, our target net is the strobe with a delta of 0. This is the longest routed net. So all nets in byte lane 0 must be within the tolerance value of our target net. So now that the actuals are updated, I can review the range and delta columns for each net in this constraint class. The delta column will display gray if there is no violation, yellow if the tuning is close to the tolerance value, and red if there is a violation. So for byte lane 0, we can see that all nets show gray in the delta column, meaning that our tuning was successful, and we have one net that shows as yellow. So this is not a violation, it just means that this net's length is close to the tolerance value. And let's go ahead and take a look at byte lane 1 and verify the same thing. Here we can see that all of the columns are gray, and in this case our target net is DQ13 with a delta of 0. So this is our longest target net. If the actuals are required to be viewed in the front-end schematic, the actuals can be manually exported from this back-end constraint manager database by using the file export actuals command seen here. If desired, the actuals can also be set to automatically export to the front end by defining the settings in Expedition Designer. So with the first 2 byte lanes verified, you can exit the constraint manager. The board has been fully tuned and the actuals verified against the defined constraints in Constraint Manager. So Wilfred can now move on to ensuring the quality of the DDR4 interface in Hyperlink's DDRX wizard prior to passing the design on to Rory for final sign-off.